All right, section 3.3b, these are the notes. So we left off last time by talking about horizontal and vertical lines, right, and what those equations look like. Now we're going to jump into parallel and perpendicular, but let's remind ourselves a little bit of what we were talking about beforehand. When we were given the slope of a line with 2 points, or we were given the slope of a line with slope of something, so we were given a slope and a point, right? We could go ahead and find the equation by plugging into either point slope form or into slope intercept form. And then if they asked, we could convert it back to standard form, but that was sort of an extra thing. So we ended up with an equation that looked like this. Today, we're going to wrap in two concepts. We're going to talk about parallel and perpendicular, and we're actually going to find a parallel and perpendicular line given another line. So basically the steps today are written down right here. Got a nice, easy step-by-step sort of situation going on here. But I find it's always easier to just do a example problem, and then if something doesn't make sense or if you forget a step, you can refer back to the steps to find parallel perpendiculars given an equation and a point. So let's just start with example 5.1. Alright, example 5.1. Find the equation of a line passing through the point, negative 4, 5, that is parallel to 2x plus 3y equals 6. Well, let's remind ourselves of a few things before we really dive into this problem. So, parallel lines. Parallel lines have what kind of slopes? Well, okay, I'm going to rewrite that. Sorry, guys, that's just not coherent at all. So, parallel lines have what kind of slopes? What kind of slopes do they have? That's right, they have same slopes. They have the exact same slope. So if line number 1 has a slope of 3, line number 2 has a slope of 3, right? So the first thing we're going to need to do is find that slope. We're going to need to find what's the slope of the first line so we can go find the slope of the second line. So here we'll start looking over this equation. How can we take this equation and find the slope? Well, we can either plug in a couple points until we find those points and then use the slope formula, or it'd be much easier to just rearrange this into y equals mx plus b. So let's start with that. First, we're going to find the slope. We don't need to write this because it's been written down. So first, we're going to find that slope. Number 1. So I've got the equation 2x plus 3y equals 6. 2x plus 3y equals 6, right? That's what I have. I need to put that into a slope-intercept form or into a point-slope form so that I can see the slope, right? Standard form as it is does not show us the slope. So let's go ahead and rearrange. Seems like you guys like point-slope form, or slope-intercept form, pardon me, slope-intercept form a little more, so let's go ahead and do that. So I'll subtract 2x from both sides. The goal is to get my y by itself. So I have 3y equals negative 2x plus 6, divide by 3, and I end up with the line y equals, I don't want to write it there because I'm running out of room. I'll go write it up here. Y equals negative 2/3 x, and then 6 divided by 3 would be 2. Remember, you have to divide 3 to everything. Just like when we're converting back, we have to multiply that 3 to everything, right? So make sure that when you divide, that b also gets divided into a 2. All right. So now that we've done that, this is all just still the first line. We have not found another equation yet. So we found the first line. We need the same slope. So what slope is here? What can we call slope number 1? Good, negative 2/3, right? That's the slope here. Our slope number 1 is negative 2/3. So this is all for the first line. We'll call it line 1. This is the first line. Slope 1 is negative 2/3 for line 1. Now for line 2, we can use a different color. What does that slope have to be? What does that slope have to be? It's not a trick question. Right, it's got to be exactly the same. It's got to be negative 2/3. So we know that this slope is negative 2/3. Fabulous. All right, we found the first thing we need, slope. Now the second part we need is to find the equation. So if you have any questions at all, make sure you pause on how to find the slope. We need a matching slope here. Alright, so now we're going to change, or basically what we've been given now is a problem where they gave us a slope, m is equal to negative 2/3, right? And a point, let's see, what was the point they gave us? The point they gave us was negative 4, 5. And now it sounds exactly like the problems we were doing last time. Here's a slope, here's a point, go find the equation, right? So once you find that slope and you're given a point, you can find it either through point-slope form or through slope-intercept form. I'm going to do point-slope form. So y minus y1 is equal to m times x minus x1. Alright, I'll plug in my slope and I'll plug in my point. So I've got y minus, let's see, my y here in the point was 5. You know what, I'm going to write a little smaller because we are running out of room. So y minus 5 is equal to, let's see, that slope is negative 2/3. X minus, and that point, the first half of my point was negative 4, minus a negative 4. Watch those double negatives, right? Alrighty. Now I will simplify a little bit. Simplify just a little bit. If it asked for it in point-slope form, this would have been a perfectly acceptable answer, right? I could just leave it right here. But since I'm used to saying it in y-intercept form, or maybe you did it in y-intercept form and you want to make sure your answer matches, let's just simplify a little bit. So I can distribute that negative 2/3 in. Y minus 5 equals negative 2/3 x. Let's see, that would be a positive 4 times 2/3. Times negative 2/3 would be negative 8/3. And then I add 5 to both sides. Y equals negative 2/3 x plus, let's see, that would be 15/3 plus or minus 8/3 would be 7/3. And there's our equation. Sorry guys. Alright, so this equation, this line 2 here, this line 2 is going to be parallel to this equation because, notice it's got the same exact slope, and different y-intercepts. So that's how you would find the parallel line to this first one. And we know that since we use this point to find this equation, we know that this one would go through negative 4, 5. Alright. This next problem right here, problem B, is extremely similar. In fact, I believe the only things that are different are the points in the equation. So I would like you to try it first. So go ahead and pause this video right now, and I want you guys to try it on your own. Okay, so try the same thing. You're going to take line 1, find that slope, find the same slope, and then find me a new equation. Alright, go ahead and try that now. Alright, I hope you paused the video. We're going to do this, I'm going to do this very quickly. So if you hadn't done it already, remember the worst thing you can do is not try in class. You need to try it in class, otherwise what's the point, right? If you think you can do it now, that's great, but you may be wrong. You may be wrong, and then you're going to go home and have 4 hours of homework because you have to do this like 50 times. So don't put yourself in that position. All right, we'll start with line 1. Oh, sorry. So line 1 has the equation 3x minus y equals 8. Minus y equals 8. We can rearrange that to find the slope. I know I need the same slope, so we'll rearrange that. Negative y is equal to negative 3rd x plus 8. Subtract the x over. Divide everything by a negative, so that y is positive. You get 3x minus 8. Alright, so my slope here is equal to 3. It's my slope 1. My slope 2 needs to be exactly the same. Let's use a pretty color. Let's use like purple. My slope needs to be exactly the same. So M2 is going to be 3 as well. Now, and then it goes through the point 7, 2. Now I can solve this like last time. I have a slope of 3 and a point 7, 2. I'll mix things up. I'm going to use the y-intercept form in case you did. If you did point-slope form, you still should have gotten the same answer. But I'm going to use y equals mx plus b. So I'm going to plug in my 3, my 7, and my 2. So y is 2, m is 3, x is 7, and I get b, or plus b. Remember, b is the part I'm solving for. It should not be the part I plugged in for. Alright, 2 is equal to 21 plus b. 2 looks like b, so minus 21 to both sides. You get negative 19 is equal to b. So y is equal to 3x minus 19. And we have our equation. Notice this has the exact same slope as the last one, right? But it has different y-intercepts, so they are indeed parallel. This is line 2. Alright. Hopefully that's what you got as well. Alright. The next one is find the equation of a line passing through point negative 4, 5 and perpendicular to 2x plus 3y equals 6. This sounds verbatim, this question, except for one word. What's the only thing that's different between these two? That's right, the word perpendicular. Let's remind ourselves what that means. Well, perpendicular lines, right, intersect at a 90-degree angle. But what does that mean about their slopes? So we can go back up here. Perpendicular lines do not have the same slope. They have what? Opposite reciprocal slopes. If you didn't remember that, you need to make sure you remember what that means. Opposite reciprocal, and it has to be both, right? So 2 would become negative 1/2. So positive 2, positive goes to negative, 2 becomes 1/2. We can leave that a little note right here. 2 becomes negative 1/2. That's opposite reciprocal. Alright, let's go down and actually do that now. Other than that, it is literally the same problem. It is just exactly the same. So since, again, we're dealing with slopes, right, opposite reciprocal slopes, we should put that note down. Since we're still dealing with slopes, we need to find the slope of this first line. So let's go ahead and find that slope. Well, we already did, but let's do it again just for practice, right? So line 1 is 2x plus 3y is equal to 6, right? So we can subtract 2x from both sides and get 3y is equal to negative 2x plus 6. And then divide by 3, we get y is negative 2/3 x plus 2. And again, we can see that our slope is right sitting there next to x, so slope 1 is equal to negative 2/3. I'm going to write that a little better. Negative 2/3. Right? Alright, so once y is by itself, we can find that first slope. So that's all for line 1. Now we have to be careful. At this point in the last problem, we deduced, okay, we needed the same slope, right? Parallel. I needed 3, I got 3. I had negative 2/3, so my next slope was also going to be negative 2/3. Here, that is not the case. Here, my next slope is going to be the opposite reciprocal from that, right? So the opposite, well, this first one's negative, so this one's going to be positive, right? And then I'm going to reciprocate it, or I'm going to flip the fraction over. Positive 3/2, pardon. Positive 3/2. So it's not going to be negative 2/3, it's in fact going to be positive 3/2. It's going to be the opposite and reciprocal. But from there, once we've done that, it's the exact same problem. So we can take that new slope, m2 is equal to 3/2. And the point, let's see, what point did they give us? It was the same exact point, so negative 4, 5. And now it's just the problem where we have a slope and a point, and we can go and find the equation that matches using either point-slope form or a slope-intercept form. Once again, I'm going to use point-slope form just for repetition's sake. So let's keep going. So y minus y1 is equal to m times x minus x1. Plug in what I know. I know that the y1 was 5. The m was positive 3/2. And the x1 is negative 4. Alright, looking good. And then I can simplify a little bit just to make sure we match with anybody who might be doing it point-slope form, right? Or sorry, slope-intercept form. Want to make sure it's the same thing. So we can distribute that 2/3. Get y minus 5 is equal to 3/2 x. Let's see. That would be a positive 4 times that would be 12 divided by 2 would be plus 6. In case you didn't catch that, positive 4 times 3/2 would be 12/2 or 6. Right? So that's what I did right here. Alrighty, and then I just have to add 5 to both sides. I end up with the line y equals 3/2 x plus 11. And there is my line. Notice these two are not parallel. They do not have the same slopes, but they do have opposite reciprocal. Negative 2/3, 3/2. They do not have matching y-intercepts either. Never is that the case. Their y-intercepts should never match. But they have opposite reciprocal slopes. Alrighty. This next problem is virtually the same, right? It's got just a different point, different equation. So I'm going to let you guys handle it and take a look at it, get questions answered, try it out. Go ahead and pause the video and give yourself a shot. Alright, hopefully you pause the video. I'm going to do this pretty quickly because you should already have it done on your page. Remember, if you don't try, the only one you're hurting is yourself, right? So let's try this out. So I've got this line, it's line 1, green, of 2x minus y equals 7. So line 1 is 2x, come on. Sorry, one sec. Okay, let's get ridiculous. Line 1 is 2x minus y equals 7. Got to rearrange that to find my slope. So negative y is equal to negative 2x plus 7. Divide by a negative, or divide by negative 1, you get 2x minus 7. So m is equal to 2, m1. That first slope on the first line is equal to 2. Now for m2, I don't want the same slope, I want perpendicular, which is opposite reciprocal. So right now it's a positive slope, therefore my opposite reciprocal will be a negative slope. It's a 2, so it's going to be a reciprocal of 1/2. So change the sign, change the fraction, right? If it's a whole number, it's 2 over 1, you flip it over, it's 1 over 2. And then my point was 8, 5. So point of 8, 5. And I'm going to use that to find my equation. Just like last time, I'm going to switch it up. Instead of using point-slope form, I'm going to use slope-intercept form, because why not? They're about the same amount of work. So y is equal to mx plus b. And I'm going to plug in what I know. I know that y was 5. I know that m was negative 1/2. And I know that 8 was x. But I don't know b, right? Because neither one of those said 0, something, right? Or, sorry, 8, 5 is definitely not 0, something. So now I'll solve this out a little bit. I have 8 times negative 1/2. Well, that's 8 divided by negative 2, or negative 4. So 5 equals negative 4 plus b. Gotta make that look prettier. Negative 4 plus b, right? So what plus negative 4 would be 5? We'll add 4 to both sides, and you get that b is equal to 9. So my final equation is y equals negative 1/2 x plus 9. Should have gotten the exact same thing with point-slope form, no matter what. Alright, that is parallel and perpendicular lines. Alright, the last thing we're going to talk about is modeling real data, but let's just review this part real fast. So finding a parallel or perpendicular, you first need the slope, then you need to find out whether you need the same slope or an opposite reciprocal slope, and then you solve it given point-slope form or slope-intercept form, either one. Alrighty, cool. That's pretty much summarized in these forms down here. You've got this forms of linear equation. You can see we've got the y equals mx plus b, the slope-intercept form, tells you where it would be applicable. You've got your point slope form, you've got your standard form, so and then where they would be most useful. But remember, you can convert between any one of these, And then down here, it's got also the slope, the horizontal line, and the vertical line. So this might be a good thing to keep in your notes for when you're studying for that quiz coming up, right? Hintity hint hint, or the unit test. This might be a good thing, or even just later on in life, it might be a good thing to keep like committed to brain, or at least have it sort of as a backup, right? The last thing we're going to talk about in chapter 3.3, section 3.3, is going to be using equations to model real data. So more of that real life stuff. That where would we actually see this in the real world, and why should we care? So let's look at some real life examples and see if we can fit linear equations to them. 6.1. Suppose it is time to fill your car with gasoline. At your local station, it costs $3.20 for 89 octane gas. We'll talk about that in a sec. Write an equation to represent the y cost for x gallons of gas. Well, so first off, 89 octane is a way they used to define gasoline. Now they just put it as leaded, unleaded, and premium and stuff like that. In fact, they don't even use leaded anymore. It's kind of an old problem, so sorry about that. Also, this is a little bit more expensive than we have here in Utah, but if you ever choose to move like to California, $3.20 a gallon is probably what you're going to be seeing, so that's something to keep in mind. Okay, so let's think about what happens when you go to the gas station, right? When you go to the gas station, what do? Well, you pull up your car, you undo the little nozzle, and then you pick which kind of gas you want, you put it in, right? And you're thinking, okay, maybe you've got 20 bucks, right? You've got a gas allowance from your mom, or maybe you made 20 bucks at your job, and you're thinking, okay, I've only got 20 bucks to spend on gas. How much can I actually put in? Well, you're actually thinking in terms of a linear equation, right? You're thinking, okay, I need this cost for some gallons of gas, right? So $3.20 a gallon, right? So how can we set up an equation that would look like this? Well, I have this $3.20, right? And if I want to find out how much I'm actually paying, I'm going to multiply that by how many gallons I put in. Now, if it's X gallons, if it's 2 gallons of gas, I'd multiply by 2. If it's 1 gallon of gas, I'd multiply by 1. If it's 15 gallons of gas, I'll multiply by 15. And that will end up giving me my cost for the whole, the whole gallons of gas, right? It'll give me my bill for using the gas pump. So sometimes you'll say like this. We can also write it as y equals 3.2x with no y-intercept. And that is our equation that models real data. All right, let's take a look at B. Now suppose that you want to get a car wash for $3 then for filling up at the station. How does that change your equation? So if you've seen this a lot, right? It asks you at the end, do you want a car wash? And they'd be like, yeah, sure, dude, my car's dirty, it's summer. How is that going to factor into your cost here? Well, you're still going to have that total cost of 3.2y or 3.2x, right? So we're still going to have to pay for the gas, whatever that means, right? The 3.2 times the $2, or the 2 gallons, or however much you put in. And then what on top of that? Are they going to charge us $3 per gallon? Are they going to charge us $3 total? Like, what's going to happen? Talk about that for a sec. All right, good. So they're going to talk about it they're going to only charge us the once, right? They're going to charge us one $3 car wash. So it's going to be a constant, right? It doesn't depend how many gallons we put in. Some gas stations, they do. But in general, in this one, it didn't matter how many gallons of gas we actually bought. We just wanted a $3 car wash in addition to. So it's just going to be a constant of 3 on the end. And that's still going to be, all of that is going to equal our total cost of the gas station. Alrighty. Now interpret this as interpret the ordered pairs 519 and 1035 in relation to your equation. So we have this equation here, right? We have this equation y equals 3.2x plus 3. What does this ordered pair 519 mean in terms of context? Now, of course, we could plug it in, right? We can plug it in. 19 equals 3.2 times 5 plus 3, and we know that's true because we get 19 equals 19. And so it is an actual solution, remember way back when we called these solutions, to this equation. But what does it mean? Why do we care? What does that mean here? Like, what is 519? Well, if we go way back up to A, we realize that X is the gallons. So for 5 gallons, it's going to cost Y, or in this case, $19. So if that's what it means, 5 gallons is going to cost $19. It costs $19. Same thing goes for this other one. So talk about that for a second. What does the ordered pair mean, 10, 35, right? What does it mean? Alrighty, it looks like it means for 10 gallons, it's going to cost $35, right? $35. That's what that means at the end of the day. And if that's, maybe, hopefully that's true, right? 32 times, or 3.2 times 10 is going to be 32, plus 3 is 35. So yes, that's actually true. It is a solution. And it means that for 10 gallons of gas, it's going to cost $35. So if you only have 20 bucks in your pocket, you're probably going to go with the 5 gallons instead of the 10 gallons, right? Or maybe you'll ditch the car wash or something like that, right? So you want to make sure you can plug in and stuff like that. And that's basically how equations model in real life. Now, you've already been doing this in your head when you go to the gas station and you think about the fact that you have $20. Granted, you don't use X and Y, but you do think about it this way. I guarantee you, unless you are horribly bad at math and you think that you can get away with 10 gallons for 20 bucks, in which case the machine will yell at you and your parents will yell at you. So when you do stuff like this, you're really doing this linear equation nonsense, right? Or it's not really nonsense, it's very practical. Let's try another one. Scroll down a little bit. And it looks like mine got cut in half. Hopefully yours didn't. So make sure you've got all points from 1990 to 2002. But the average annual cost and fees for in-state students at a public four-year college are shown in the table below for selected years and graphed as ordered pairs on the scattered diagram, which I did not include, so I apologize. Where X equals 0 represents 1990, and X equals 4 represents 1994, so on, and Y represents cost in dollars. Alright, so find an equation that models the data, and then use the approximate cost of tuition at a four-year college in 2014. So first we're going to find an equation. We have this data. I'm not sure if yours also has the graph. Sorry, one sec. Yeah, yours actually has the graph, which is nice. Mine doesn't for some reason, but that's okay. We don't really need it, to be honest. We don't need it at all. Just need this table. So we want to look at an equation that would solve this. So let's look at a y equals mx plus b, because that seems to be everybody's favorite form. So what two parts do we need to plug into this? Well, we need a slope, and we're going to need a y-intercept, right? So we're going to need the m, we're going to need the b. Let's start with the slope. Let's start with that slope, right? So slope, we want to find, if we want to find m, we're going to need that rise over run, or that y2 minus y1 over x2 minus x1. Where am I going to find these four numbers? Well, if I look at this table, I've got nice even coordinate pairs, right? I've got 1990, comma 2035, all the way down to 2002, comma 4273. So I'm going to use those as my points. I'm going to use the point 1990, comma 2035, and the point 2002, comma 4273. So I'm going to use those 2 points. Now in the problem itself, if you're looking on the graph, you'll notice that it's got x is 0 at 1990 and x is 4 at 1994. So what they're doing is they're saying each year represents like the last part of it. So 2002 would be how many years from 1999, so, or 1990? That would be 12 years. So in 2002, x would be 12. Here, I'm just going to use, for the algebraic version, I'm just going to use these. Okay, so I'm just going to use this. It shouldn't matter. Either way, you'll get the same answer. So let's plug these in. Y2 is going to be this number right here, right? The second y. So 42, subtract the y's, 4273 minus 2035 over 2002 minus 1990. And when we compute that out, we get the top of 2238 over 12. or an average of about 186.5. Now, before we move on, before we even talk about anything else, this number represents the slope. Yes, we just found m, right? And that's great. But what does it mean in the context of the problem? What does this mean? 186.5. That's right. It means $156 per year. That's what that means. Dollars per year, right? So it's going up at an average of $186.5 per year. So that's important to know. All right, so we can go ahead and put that in our equation. $186.5 times x plus something. Since we're going y equals mx plus b form, we can do, we'll use the y equals mx plus b version. However, you're more than welcome to plug it into point slope form and end up getting the exact same thing, right? So you should be able to get the same thing if you did point slope form. Alrighty, so now we'll plug it in. We're going to take any one of these points, right? If you're given 17 points, then you can use any of the 17 points. I'm going to use the smallest one, though, which really doesn't make a difference. I'm just going to use this first point, 1990, 2035. So 2035 was our y. Our slope was, okay, I don't know why I wrote a point there, 186.5 times 1990 plus b. Alright, now we will multiply that out. Whoa. I'm sorry, it does make a difference. So here, we actually want to put in, so now we actually want to use the fact that x represents 0. So here our x is not 1990. It's going to be 0. The way they've set up this problem, the x coordinates to 0. So, got a 0 plug in. 0 cancels out. You get 2035 is equal to b. And so I've got that. My equation is y equals 1.86.5 x plus 2035. Alright, so we found our equation. And that 2035 means we start at 2035, which we do, right? We definitely started at 2035, and it went up to it went up by $186 per year. I wish this was a little more accurate because that is not the case, right? College tuition definitely is not $4,000. This is probably more of a two-year school, a two-year public college, associate's degree, something like that. But yeah, this is a pretty standard equation. Last thing we have to do is actually find the tuition in 2014. So if x is how far away from 1990, if x is how far away from 1990, so x equals 0 in 1990, what does x equal in 2014? That's the question. Does not equal 14. Equals 24, right? It equals 24. So it's 24 years from the year 1990. So let's plug in 24. Plug in 24. So y equals 186.5 times 24 plus the 2035 to start. And we can either do that by hand or by calculator. We end up getting about $6,511. That's what it's going to cost us in 2014. Questions? Alright, now you could have done this from the graph as well. You could have found points on the graph. You could have found a y-intercept on the graph. Would have been the same thing. But either way, you should have ended up with virtually the same answer. Your graph might be a little off because you have to estimate a little more. So I would always go with some ordered pairs given. That way it can be most accurate. Alright, let's take a look at one more. Retail spending in billions on prescription drugs in the United States is shown below. Write an equation that models the data and use it to predict drugs retail spending in 2007. So we have this bar graph here. It's not a line graph, but it's a bar graph that shows us the retail spending in prescription drugs. This time we have to use the graph, right? Because we're not given a nice table of coordinate pairs, right? But it's essentially the same. We need an equation. We need, no, lime green's horrible. Let's do red. y is equal to mx plus b. We still need that, right? At the end of the day, that's what we need. We could do it in standard form, we could do it in slope-intercept form, either would be fine. But we seem to be most comfortable with this, so we'll go with that. Y equals mx plus b. Still need a slope, still need a y-intercept. And since we still need a slope, we're still going to need a slope formula. So every time you need a slope, you need the slope formula, unless it is given to you. Other than that, you will need the slope formula. So we'll do m is equal to y2 minus y1 over x2 minus x1. And now the question comes down to, where on earth are we going to get these 2 points to find the slope, right? Well, it looks like they're going to tell us here. So we need years by spending, right? So we need 2 coordinate pairs, just like last time we had years by cost, same thing. So our x is going to be from 1999. So we'll say that x is defined 0 at 1999. So we have the point 0, comma 126. Sorry, 126. My grandma likes to text me. And we have the point, let's see, over here at 2004, that's going to be 1999, 2000, and then 4 more, so 5 years after 1999, it's going to be 2221. Sorry, 221, not 2221. So once again, this x thing I'm doing here, I'm saying if x is 0 at 1990, then I'm looking at the years past 1999, right? So if 1999 is 0, then 1, 2, 3, 4, 5 years later is 2004, or 5, comma 221. That just makes the numbers a little smaller. You don't have to do that to find the slope, but you will eventually have to do that when solving for the y-intercept, if you need to solve for the y-intercept. All right, so let's plug that in. We've got y2 minus y1, so 221 minus 126 over 5 minus 0 is equal to 95 over 5, which is equal to 19. So what does this number 19 mean? What does it mean? Alright, that means $19 billion per year. Right? We have to be very careful about that. Notice this is spending in billions. So this is $19 billion per year. That sounds about right when you're dealing with the entire United States, right? $19 per year does not sound right when you're dealing with the entire United States. I mean, I wish it was going up $19. It's like not even a cent for each of us, but 19 billion sounds a little more accurate. All right, so far we have y is equal to 19x plus some b. Now we could pick any of these points for b, but remember, what is b? B is the y-intercept, right? It's the corresponding y value for the y-intercept. Do you see this y-intercept on the page? You're right, it's right over there. That's our y-intercept, 0, comma something. So if you want to save yourself 20 seconds, then you can just say, oh look, 0, comma that value, therefore b must be that value. Y equals 19x plus 126, right? Because this is our y-intercept, we know it's 0, comma b, therefore we know b. We don't need to go and solve for it, it's fine. All right, so that is a nice little shortcut if possible. We could have done that in the last one as well. Notice when we didn't, we used 0, we still got the same b, and that's totally fine. You're welcome to do that, but it's a little shortcut. If you see the 0 on the page, you're welcome to use that y-intercept. Last thing we got to do is actually solve for what they want us to solve for. So we found the equation that fit the data, but we need to use it to predict the drug sales in 2007. So let's take a look at that. So y equals, well, what would x be in 2007? If it's 0 at 1999, x would be what? In 2004 it was 5, 2005 is going to be 6, 2006 is going to be 7, 2007 it's going to be 8. So we're looking at x equals 8. So y equals 19 times 8 plus 126. So we're plugging in 8 for our x because x equals 8 at 2007. All right, and let's go ahead and solve that. So 19 times 8 plus 126, it looks like y is equal to 278. And that's awesome. But what does that mean? That means y is equal to $278 billion or 2.7 trillion. Either one would be acceptable. 2.78 trillion. And that would answer our question. Really, the second one is the only one that makes you sound like a smart person, but, you know, if you were working with this, you just remembered to tack on the billions, I probably wouldn't take you off for that one. But trillion is really the more accurate one. Alrighty. That closes out 3.3. So just a little review. We were talking about, we talked a lot about how to find a parallel and perpendicular given a line, right? So given one line and a point, finding the other line, whether it's parallel or perpendicular. And then we talked a lot about modeling data through linear equations. If you have any questions on that, let us know. Or other than that, you can just start your homework. We will have a quiz next time, so please make sure you study for that. Your homework will have a review on it for the quiz. Other than that, we'll continue on to 3.4.